So what I wanted to do was just try to have a review of how to solve a rational equation. So what we have here is seen in your notes, question number 4. It's x minus 1 over 2x minus 4 plus 3x plus 2 over 3x equals 1. So when I'm solving these types of things, the first thing I want to do is just try to factor out the denominator just to see what the denominators are. So right now I have x minus 1. And when I look at these two terms, I see that 2 goes into both of them. So I'm going to factor out a 2. So I have 2 times x minus 2 plus x plus 2 over 3x equals 1. So what I want to do is I want to try to get these two terms to have the same denominator. So right now I know that this has a 2, and when I look at this next one, so I see this one has a 3x. So what I want to do is get both these terms to have the same thing. So what I know is that this one is going to need a 2, and this has a 3, so I'm going to have to give this a 3. Now, not only does it need a 3, it needs an x. So that's what this term is, and I'm actually going to multiply this one by x minus 2 as well. So what happens is these both have 3x, and they both have 2 times x minus 2. Now, not only do the numerators, but because I'm getting a common denominator, I need to, so I'm going to multiply, because I multiplied this term by 3x, I have to multiply the numerator by the same thing, 3x. So I'm multiplying x minus 1 times 3x, and then I'm going to multiply x plus 2 times 2 times x minus 2. So right now, I have the same denominator of basically 6x times x minus 2. Where did I get the 6x from? 3x times 2 gets me that 6x. I have 3x times x minus 1. And then I have plus x plus 2. I'm going to put a 2 in front of that, times x minus 2. Now this is going to equal 1. But what I want to do is I want to get a common denominator all the way across. So I'm going to take this 1, because it's 1 over 1. I'm going to multiply it by 6x times x minus 2. Now what happens is because these denominators are the same, like if I were to multiply this side by 6x times x minus 2 and this side by 6x minus 2, the denominators cancel. So now I just have 3x times x minus 1 plus 2 times x minus 2 times x plus 2 equals 6x times x minus 2. So what I want to do is just solve this equation. So I'm going to multiply these two terms by 3x. So I get 3x squared minus 3x. And I have plus 2. And if I multiply both those, I get x squared minus 4. So I have 3x squared minus 3x plus 2x squared minus 8. And then I have 6x squared minus 12x. I'm going to get one side to be 0. So I'm subtracting 6x squared from both sides and adding 12x to both sides. So I'm subtracting 6x squared and adding 12x. And what I end up with right now is I end up with negative 1x squared plus 9x minus 8 equals 0. So actually what I'm going to do is say, well, the greatest common factor between all these two terms is negative 1. So I have x squared minus 9x plus 8 equals 0. So I have x minus 8 and x minus 1, which means that x equals 8 and 1. So what I got to do is, because I want to see if these are extraneous solutions, I got to plug 8 and 1 into this equation. So let's plug in 8 first. So I do 8 minus 1 over 2 times 8 minus 4 plus 8 plus 2 over 3 times 8 should hopefully equal 1. So I have 7 over 16 minus 4 plus 10 over 24 should equal 1. So that's 7 over 12 plus 2 goes into both of those. 5 over 12 equals 1. So that checks out. So let's check out 1. Does 1 make this work also? If it doesn't, that means it's extraneous. So I'm going to do 1 minus 1 over 2 times 1 minus 4 plus 1 plus 2 over 3 times 1 should equal 1. So I get 0 over negative 2 plus 3 over 3 equals 1. So 1 equals 1. That checks out. So both these terms are true solutions. So I'll try to do the next one, and we will look at it next.